Hi, thanks for joining. In this video, I'd like to go through the topic of relation maps. The way that relation maps are different from things such as generic tables or dependency matrices are that they act recursively upon each of their results. That is a big difference between what you see in a generic table. Let's take this meta chain, for example, that starts with a beginning point, as all meta chains do. And this produces a few different things. We'll look at each of those things that it's producing, but it's actually producing an activity that is decomposed out of this initial activity and then shows another decomposition from there. And if we were to look at this exact same meta chain in a generic table, what you would not see is the linkage between each of these different steps. And you would also not see that this acts recursively upon each of the elements that are in the results. So if we go back and look at this table, notice in this case, we have all of the activities in this model, and then we're looking at a meta chain that produces the behaviors that are decomposed from those higher level behaviors by using an activity to the node, to a call behavior action, and to the behavior that defines that call behavior action. So that's a meta chain that'll produce a decomposed functional breakdown. So in this case, notice we have this activity 1 that does break down into activity 1.1, 1.2, 1.3, and all of these actually break out as well. However, what you don't see is what happens after this, right? So there may be something that breaks down after this. In this case, we don't have anything defined, but from the initialized system, notice that this breaks out into activity 1, activity 2, and activity 3. And then that activity 1 is what breaks down from here to here. So what you're not seeing is that direct linkage. You have all of these base elements here and then that one hop, but you're not seeing anything else after that. And that's where relation maps can be very uniquely advantageous, is that you can start with a single element, or you can start with an entire package of elements and then show how they recursively expand using the exact same meta chain. So what happens is we perform a meta chain that produces this step here, but then that exact same, this result is actually treated as a base element of that exact same meta chain again to expand upon that recursively until that pattern no longer exists in the results, which is a very neat way to show decompositions especially. So let's look at the architecture for this as an example. So in this case, we have this system context block, and then we were showing some stakeholders, a system of interest, an auxiliary power unit, and we show that the system of interest breaks out into some different subsystems. And this mobility subsystem, for example, has 3 different wheels, each typed by this wheel block. Now, Cameo has some out-of-the-box relation maps that you can use, such as a structural decomposition and an activity decomposition map. And in order to use those, you can create a diagram in your model, and you go to the expert mode. What you have is activity decomposition or structural decomposition. So for this first one, let's look at the structural decomposition. I've already created that here, but then let's talk about how this was created. Simply, the 2 options you have are to drag in a system context or a context block, which will be the highest level part of that architecture that you'd like to decompose. In this case, it's that system context block. It could be the system of interest. Most likely it would be the system of interest block. However, for the sake of the example, we're starting at the system context and showing each of the part properties. And if you notice, what happens is it actually recursively shows each of the part properties that have other blocks that also have part properties. So this expands until that pattern no longer repeats, and we see all the way down to the wheel level. So that's a structural decomposition map. Notice you don't even need to use the scope, as long as I believe by default, if you don't scope this, it's really the entire model is the scope. So let's look at the activity decomposition map. What you see here is this initialized system activity breaks out into activity 1, 2, and 3, and then activity 1 is further decomposed by call behavior actions that are defined by these activities. So if we look at that in the high-level activity diagram or the use case diagram, what we're seeing is this behavior is called initialized system. It's the use case. And then what we see is this call behavior action is then decomposed further by activity 1, activity 2, activity 3. If we delve into activity 1, you notice that there are actually more activities defining the actions in this activity 1 behavior as well. And that's what we can see decomposed in that relation map. So this is what that looks like here. Now, this is a custom relation map. And as I mentioned, you have the option to do the out-of-the-box relation map, which is called the activity decomposition. However, what's neat to do is customize these. In this case, what we're also looking at are some of the parameters of the activities. So a few things to know about how to set up a relation map is you always have that starting element. This could be a package that contains a whole lot of other elements. And if you were to want to expose those elements, you'd use a meta chain such as the package and then the owned elements of that package. So typically you start with whatever you'd like this to all go back to, but interestingly and different from a table is there can only be one starting element in a relation map. Like I said, that could be a package that contains other elements. However, there can only be one starting element, whereas in a table, you have each of these are a starting element of a meta chain, right? So this is a starting element. There you create a base type and then the scope, and you see all of those types, and a meta chain is performed on each one of these base elements. However, in the relation map, what you see is you have one base element that will then expand out into other elements based on that meta chain. So if we open up the relation criteria, this is where you actually create the meta chain. You can do simple navigation as well if that's all you need to do. And this is also where you color code the different types of relationships that you have by selecting a color for those specific types of relationships. So if we wanted to create a new meta chain for this, what you could do is you go to create operation and do meta chain, and then you would start with whichever type of element you would like, and then go to its property. And keep in mind, you could potentially start at any type of element that will be a result in another meta chain. So in this case, let's say I wanted to actually start my meta chain with this activity parameter. If we look at activity parameter, we don't actually see anything, and that's because it's thinking that we need to start this meta chain with the same type as this context, which in this case is an activity. But what you can do is null the context if you'd like to basically start from any type of element. Instead of using context equals this, which would be this type of element, you could simply reset this and it creates it as a null element, so it's not going to narrow down that initial base element. And then what we can do is look at any type of element we'd like to, right? So if we wanted to start with an activity parameter node, we could do that. And then let's say we wanted to see what the type was, for instance. We could look at that, right? And then any result in this relation map that began with an activity parameter node would then show a sprout of the type. And that is how you can do a lot of really unique things with relation maps, is by understanding that these meta chains act recursively on each of the results in this table, and you can stack up as many of these types of meta chains as you'd like. So notice we have the behavioral decomposition in order to recreate that, which is the exact same thing you would see in the out-of-the-box activity decomposition. Is we start with the activity, which in this case is this activity. it goes to the node and then the call behavior action and then the behavior that defines that call behavior action. So that's how we recursively see this activity decomposition, because each of the results that are an activity will then have this exact same meta chain performed on the results as well to then produce even more results, which is very, very neat. So if we look at the other meta chain that we currently have in this table, notice we start with the activity and we say any activity that has an own parameter, let's display those own parameters. And that's how you see this here. So initialized system has a parameter, it's an input that's 28 volt DC power. And if there were any other activities in here, such as this one that has parameters, you would then see those sprout off as well. Now, one other thing to add to this, they can really help with speeding up how fast your relation maps are created, is to narrow down the element type. So the element type is very important because by default, this is set to any, which means all of these meta chains will be performed on every element type in your model recursively. So that can take a while for your relation map to build. However, what you want to do is actually narrow this down to the specific types of elements that you would actually like to see in the results. So in this case, those we have activity and parameter are the only two types of elements that I'd currently like to see in here. That's why we're seeing activities and parameters and nothing else. So if anything else uses that exact same meta chain, you can filter those out by simply saying, these are the only types of elements I'd like to see in my results, by using the ellipsis for element type, and then selecting those types of elements there. Now the scope has to do with the starting element or the context element. So notice as of right now, the scope is set to the model. You typically don't need to set a scope because all of this will start with that context element. But you could narrow that down if you'd like to, if you're dealing with things such as packages. So that is an option, but it's typically one that you don't need to use for relation maps. Please feel free to reach out if you have any other questions on this topic. Thanks.